Hello, everyone, and welcome to our first special seminar series for CFIGs in the School of Earth and Planetary Sciences. Pleased to welcome you all. And our first speaker is Ivana Ivanova. And Ivana is going to be talking to us about geoscientific and positioning data exchange and integration. And the format of the seminar series basically will have a range of talks running throughout the year. Hopefully one every month. The plan for these is that they're going to be electronically recorded and hosted for posterity. They'll be available through the CFIGs website and hopefully a useful resource for the school, but also our industry partners who are hopefully listening in. And I can see quite a few are online, which is great. Ivana, thank you very much.
Thank you, Chris. Thank you, and hello, everyone. Thank you for inviting me to kick off this amazing series. I'm honored. I almost went to say I'm nervous, but I'm actually had a dry run with the lecture just now, so I'm okay. Yes, and I think this is a good topic to start with, and not because I'm giving it, but because ultimately what we want to ensure is an exchange of artifacts of sorts or information most of the time, so data, algorithms, maps, or whatnot, produced between parties. And then I thought it's timely to remind ourselves how we do that efficiently and how we do that in a fair way. Hence the topic. A bit of my background: I'm a special scientist, how they call it at Curtin, but in reality I'm a surveyor by training, and then ultimately an engineer of geodesy and cartography specialized in geoinformatics. So all I do is build information systems that work with spatial data, mostly related to geo, so on Earth's surface, but any space will do. And my role in that is, and my approach to this is whenever a system doesn't work, I want to take it apart and find the faulty building blocks and then reassemble. So what we are looking at here is to ensure the driveway from those that want to send off some information to and the recipients is without blockage and is smooth. And how do we do that? Okay, so works, not works. Yes. Oh. Well, FAIR, that's the $1 million acronym because it actually stands for the adjective meaning of the same. So why, it's something that you could have come across very frequently recently, especially since 2016, oftentimes in scientific community. Now, this is the foundational paper by the authors defining the FAIR guiding principles. So FAIR is an acronym standing for, we'll explain what later, but I thought I actually show this paper and the very first pillar sentence to me. Yes, there is an urgent need to improve the infrastructure supporting the reuse of scholarly data, and those include geoscientific data. And that's true, yes. And this was the motivator for the paper that I've checked yesterday, so the number might be actually higher, but that's a citation number that I'm not sure how many of us get in such a short time, just 10 years. So this just reflects that for various motivations, this work is foundational to most other research work, and the principles are getting adopted heavily in the community. But everybody got perplexed by the FAIR, but we keep forgetting that geoscientists, as we are at the forefront of doing this already. And the simple reason for making sure we are exchanging our resources in a fair way is that on our data and resources, a lot of money depends. Yes? So it's very expensive to actually take lightly how we exchange data and other resources. So we are doing this, and then hence our geoscientific colleagues ensure that this is reminded to the community. So we do all of that a lot, but then it's always good now and then to remind ourselves of these principles. So what FAIR stands for? Simply findable, accessible, reusable, interoperable, and reusable. Now, I'm not going to read all of this out, and we'll share these slides afterwards with the recording, but essentially what this says, give me your stuff and give it at the persistent location. So at a location that doesn't change. I don't care how you move between servers, just give me a link that will always operate. Tell me what your stuff is. So describe your stuff with comprehensive metadata. Make it accessible through open protocols. So if you're sharing through the web, use open protocols such as HTTPS, that we do every time we browse. Make it interoperable. So in describing your stuff, structuring your stuff, use a well-defined vocabulary or standard, or vocabulary coming from a standard. And make it reusable. Tell me how I can use it and tell me how you made it. Yes, so describe the lineage and or provenance of the resource. Now, and all of this is not just for human, but more increasingly for machine users. Yes, so this stuff needs to be human readable and machine actionable, and its documentation therein as well. So what I've decided to do is to walk you through one of our, well, I would say recent, but it's actually from 2019 to 2024 sequence of projects we did with yours truly, Geoscience Australia team and their Positioning Australia department. So what we wanted to have a look at in 2019, given the prominence of fair and increased demand of offering stuff in a fair, compliant way, is geodetic data, the subject or the type of resource that Positioning Australia, is it fair to their users? Yes. So, as I said, I'm a trained geodesist, but I'm a bit rusty in the domain. So first I thought, let me see how geodetic data looks like nowadays. Yes. So, and then actually it says to their users. So who are the current users of geodetic data? Yes, so GNSS for short, which is Global Navigation Satellite Systems. And I've went to various portals offering GNSS services by agencies all over, and I noticed that many of them begin with an overview of application domains where this data is used and from where these resources, data, information, services are demanded from. And as you see, they are application domains, not your geodesists really. And these application domains will hardly actually employ a geodesist on site to be the expert on all the details and necessities to understand the resource. But these types of users, they may be machines or humans nowadays, or subscription service by a little computer on a tractor. But they want to determine whether what you're offering fits their purpose. Yes, and then they don't necessarily speak the geodesy language, but they definitely have some expectations on descriptions of a resource, and they are after some sort of descriptions, or in other words, of metadata, of geodetic data. So I did a desk-based research and realized that these metadata expectations actually vary per application domain. And what you see here are the subsets relevant to each of these. Yes, so say for instance, agriculture domain looks at information about accuracy, availability, integrity, coverage, reliability. So very typical GNSS or geodetic characteristics of the service. Yes, and that varies across the domain. These are actually essential in an experiment I've conducted. Okay, so they are looking for this sort of data, and I went to do a test. So I went to look for online for some of the GNSS data from Albany Station, Permanent Station, from the dates as provided. So where's the data? First thing, I know Albany is in WA, what a surprise. I went to WA Open Data Portal to search for that string. Yes, these are all public data sets, which include taxpayers funded data sets of GNSS records. Of course, I didn't find anything on my search attempt. So then I thought, let me just find anything not dated from Albany GNSS. There were no data sets. Let's just look at what else is there from Albany. And 24 data sets. So I thought, let's look up some geodesy or whatever you want to call it. Nothing. And then, I remember, this is the WA portal, and Geoscience Australia GNSS service is Australia-wide. So let's go to Australia data portal. Nothing, search attempt number one. second attempt, I found stuff. Yes, so what is it? Geodesy continuously operating, GNSS in there somewhere in the description. So I went to the resource, okay, looked around, 1 star, let's not go there. What other information? So where is the data actually? What? GA. Oh yes, they have their own portal. That's from where data and publication is there. And then I found the same resource, unsurprisingly, and then just after a few more educated clicks, eventually, taking me a while and on a geodesy training, I found what I wanted. Yes, data set at the end of the chain. But then, is it good for me? Yes, they say here in the description, it caters for all applications. And we just saw that application requirements vary across domains. So yeah, let's just double check. Nothing, this is the metadata record. So I went for reliability, one of the elements that was expected. And through the whole list, nothing. Yes, so something suggests to me that this is not really current user friendly. Yes, but how can we make that? What's the problem? Don't we have standards to actually do this properly? Oh yeah, we do. Many pages of standards exist, so over 100 standards available, plus 25 in making as we speak, and they are all catering for all sorts of facets of geographic information, much of that geodetic. So what's the problem? Why they are not used? Simply by the definition as to what a standard is. So this is from Standards Australia. You'll find the same thing on ISO website. Standards are voluntary unless otherwise imposed. So if your boss tells you use a standard, you do it. But they are just voluntary documents. But not only that, even though we have comprehensive metadata standards or data standards that are allowing to describe our resources, these are very lenient, yes, open, and there is a reason for it. And for instance, ISO 19115, that's a standard, things a bit weird to say about my favorite standard. It has more than 400 elements to describe a resource, yes, but out of those 400 plus, only 4 are mandatory and not necessarily helpful, yes, so if you want to say, here's my metadata record at ISO compliant, then you provide resource title, abstract, metadata, timestamp, and the creator. You know nothing, not necessarily get information about what's the reliability of quality. So, but then let's look at those, the list of standards on the right, and all that apply to geodesy domain. Yes, I've selected these and checked for support for FAIR. They are actually pretty good. Yes, they support all the principles that are defined by scientific community. So if using these would improve our fairness. But do they also offer support for user requirements that are varied across domains? Not necessarily. So I checked whether any of these provide an option to actually announce information about those metadata defined. So I did a little review what needs to be done. Essentially, in summary, what needs to be done is to improve on the content of metadata. And with that, we also went back to our actual users because the previous review was desk-based. But here we did a structured survey to the widest community of users and look through the whole GNSS value chain from the satellite sector through to service providers in between to end users and ask them what they thought about our identifying their elements and the format these are provided with. And with that, we had to think how to address those gaps to improve on how Positioning Australia actually documents their resources. What we did, we've actually decided to create a metadata profile for the GLSS community. Now, why use standards? Why would you do that in a standard compliant way, and specifically the 1900 series? Now, I saw my genius friend online, actually, so Leslie Wyborn, who in 2005 was in Geoscience Australia, actually explained the best way possible what interoperability means, you know? So this is something, when you use standards, you get this for free, yes? And then your users don't have to care how you actually structure your data and what the nitty-gritties are at your end. They are able to consume your resource immediately. But why the 1900 series? So that's a series of standards for geographic information geomatics. That includes geodesy, obviously, but how this is applicable to geoscience, very much so, because they are looking at all facets of geographic information. So there's hardly a thing that's not standardized related to the structure, to the documentation of geographic data. And as I said, there's lots of them, and they are produced as we speak. Now, but what is the profile? As we saw that out of those standard provided metadata collection, not everything's mandatory, but some domains might require more stringent obligations. Some domains have extra elements to describe their resources with, as we saw those data quality requirements essentially from GNSS community. So there is one genius rule in ISO 19115 is that this is 400 plus we identified for you, but go ahead, extend it as you wish. And it's underutilized power of the standard. So what we did is we went through all the elements, reviewed the obligations, made some more stringent, added new metadata elements, and allowed different or new domain values. And this all in cooperation with other standards and with the best practice in the community, as in region. Yes, so ICSM is the mapping agency, society community committee, sorry, for Australia and New Zealand. There is best practice how you provide metadata, which is well adopted to in GeoScience Australia already. And we just adapted it to suit the GNSS requirements. As I said, some of the elements were obliged to be more stringent, and some new elements have been added. And not only that, but in this profile, we've actually tapped into the community knowledge and power. We also used a specific encoding language to define data sets, and this is geodesy. And that is similar for geoscientific data called geosimil, water ML. We have all these standards available for different communities. So the profile selects subset of various standards and adds new documents. And through these now we have specific product types we can actually describe. So things like data stream and cyclone, which is very GNSS specific. But physical samples are possible to describe as well. We have conditions. So if you provide information on cyclone, something in addition must be mandatory. We have provided different ways of expressing constants. Yes, so we have in geographic information, we say extent is defined by geometry or address. But GNSS applications typically say extent in terms of global, local, regional. Yes, and that sort of characterization is not possible. We added extra elements, and that's where they fit it. And the biggest actual extension and advantage is extending the data quality metadata standard by ensuring there is a record in a form when filling in the metadata record where information can be provided. Now, after this, we've actually looked at the most popular application that is used to set up catalogs. So things ECAT, Geoscience Australia uses, is powered by this tool, and we've implemented the profile. And it was actually quite straightforward because this is an open source standard compliant tool and speaks the language. So it is actually speaks the standard we used. So it was straightforward to translate it to that. And getting proper metadata records with values expected by the community. Now, it's all nice and graphs and all sorts of diagrams, so obviously I don't expect you to read all through that, but let's just see what is possible to do with it. Once you have that record populated in your catalog, you can have user-facing interface to actually help them specify what is the meaning of fitness for use for them. So this screenshot is the data repository from Positioning Australia's data portal, where users typically would indicate their site, what format of the record they need, what sort of file information in the file from what period, and that was all. Now, with this metadata profile implemented, what they can do is say, I'm coming from agriculture and I do farm machinery guidance with this data. And the system actually populates the suggestion of a resource. We think this is the best for you. And then they say, well, but we also need a little higher accuracy. They can change it, and the system actually goes back and refines the search with another subset. So the work in conceptual modeling of the profile and the background actually empowers the user-facing front to exchange resources. Now, early adopters of this, as we speak, we are expecting implementation in production, and given our approach, it is pretty seems to be feasible to have this operated by where the data is produced. So the central operation of the catalog just enables a different form to fill, and we can define the ways to actually populate it. Yes, some of it is onerous manual, but there is a lot that can be automated and updated as we go. But we've also had interest from Canada's NRC, so Natural Resources Canada. They wanted to do similar thing for other geoscientific resources that they cater for. How do they do that? Also from the Agency for Data Supply and Efficiency in Denmark, because they are striving to do the same thing. But the biggest achievement is that this approach actually got picked up by Global Geodetic Observing System, which is a community that caters for a wide range of geodetic data. And we are looking at how this can be actually expanded to other dimensions of geodesy, not just GNSS. And I think there's quite a huge success of that project. And it just proves that organizations are keen to improve their fairness, compliance, and maybe that sounds a little bit technical, but they want to improve their interaction with consumers of their deliverables. And that's what this is all about. And so, well, just a few take-home messages. I don't want to do a lecture, but I think the very crucial is know your users, but know them, not just assume, because that used to be a biggest throwback in a legacy throwback of agencies producing national, federal, I don't know, coverage of spatial data. They were just thinking they know who their users are. As you saw from the examples of GNSS community, this may change in time. And for instance, European GNSS Agency does, since 2020, they're continuously monitoring the evolution of the user base. So there are surveys every year, how their requirements change, what else do they require given the technological progress. Use the FAIR principles. They are good and well established, and they are not just nice to have. Soon, as many of our colleagues that publish in Nature Science will know, this is a must. Yes, so if you provide your research outputs, you need to provide your data resources in a fair way. Yes, they dump your data sets to this portal because it's fair. Now, use standards in your domain. And it's not, again, not increasingly non-voluntary decision, because if you want to be fair, that means you use standards. Yes, that's the I in the acronym. And ensure you curate your resources. Establish mechanisms to keep updating your metadata. Some of it can be automated, and people know how to do that. But also, the last point, bye-bye are the times where the only users were humans. Increasingly, machine use automatic decision mechanism for fitness for use, meaning you need some machine encoded data and structured well to aid this consumption to avoid rubbish in, rubbish out, and disasters as a consequence of it. And what we demonstrated, that's actually machine encoded. Well, thank you. That's it from me. I'm not sure how am I doing with time. Thank you very much.
Thanks, Ivana. We'll just see if there's any. Thanks, Ivana. We'll just see if there's any questions either online or from the floor. Okay. Oh, we go.
Yes, please.
Thank you. I understand the importance of this, having been in the remote sensing domain. We are thinking through the same sort of constraints. The one thing which, and it's so useful to access data, to be able to merge data, compare to most of the things. But is this addressing the crucial point of the data quality at the end? Because as we all know, you have many groups claiming that they are doing as best as they can to collect all sort of data in the field, but you know, sometimes the quality is not there. And we need a way to know this. In the remote sensing domain, what has been brought forward is that people have to provide uncertainties with their data. And I just wonder whether it's becoming a requirement, or at least a strong recommendation in all these principles. With any geophysical data, you have to provide uncertainty. So people at least have some qualitative way of knowing whether the data is good enough for what they have to do.
It's a great question, David, and maybe just to sum it up, does this approach ensure data quality information is provided? It doesn't, yes, but it improves on the comprehensiveness of your metadata record, and by making some of those values obligatory, it actually goes towards the direction you have some information about qualitative indicators as part of your metadata. But where that information comes from depends on the procedures of quality evaluation as part of your data production. So it's up to the producer to ensure they do the proper mechanics to actually come up with those values. Yeah, so this is, and the having an appropriate metadata profile directed to the community assures only that they are given the information they expect. Now, whether the values are correct or whether the quality is sufficient is up to them to determine, and foremost up to producer to provide. Yes. Is that? I wish I could say yes, when we have this in place, then we will have high quality resources. Yes, but.
I have a question. Okay, thank you so much. As a person from GNSS community, I understand how useful to just easy to get the data from the servers and all of this area. I have a question. Now we have a GNSS network here, including several GNSS receivers here on campus, UWA campus. And what if we want to have such tool in our data? What should we do?
Thank you for the question. Very good, and I like the initiative. Yes, so depends on where your content goes. So if you're in this case, if the station is part of the course network, you would most likely transmit your data to the repository of positioning Australia. Once this profile is implemented there, they would be able to curate it at their end. Now, if as coming from outside and or from different domains, so what you need is to have a mechanism to actually advertise your resources. And that mechanism is the catalog typically, yes? And depending on the software running the catalog that there are available off the shelf open source, you can tweak it your way, yes? With this profile, what you can is you actually get a template, you can load it to that software, and there you go, you are ready to go. If this goes to another geoscientific domains, we must do an iteration to review user requirements to ensure we are providing the proper metadata content as expected by the user community. I don't want to say we have to run 4-year project for that, but there needs to be a mechanism in organization that takes their end user seriously to actually invest to this, to not miss the mark, you know, because then otherwise the resources sit there on the web and just keep getting unnoticed.
Thank you for the presentation. So as far as I understand, this searching mechanism is already adopted by Geoscience Australia. Okay. Yeah. So, and now we can go there and start like say that we are from this like sector or field and we are looking for this data, and they can give us such data. So the question, if someone from a different sector, but they don't know where to find these data from the first place, how they can go, and I mean how they can know that they can go to Geoscience Australia and find this like searching engine over there. So is it somehow capable, like, or possible to have this same profile, searching profile, to suggest, say I'm from agriculture sector, and now I'm looking for something to improve the positioning of my machinery, so we can have the same selections and so on, and then we will have like suggestion for this website, this website, this website. Even later on, we can have like rating for each website, which can reflect the quality of the data that they've mentioned, based on like reviews or like quality or something like this.
Yeah, good question. Thank you. So first of all, it is, I wouldn't say now going to Geoscience Australia. We are in advanced negotiations to have make this a reality and implementation. And what that will allow is just a few slides back, you know, that updated user-facing user interface for them to actually specify a bit more on this one. Yes, but this is just how you interact with your users that subscribe to your services. So it's positioning Australia's decision to have that interface. Now, when you, as a user coming from elsewhere, you can say, oh yeah, you're close to agricultural, not necessarily farm machinery and guidance. You could operate these values to change it to suit your needs. But once, how do you get there? Now you get there from, you know, you send students to the library, they go to Google. So you start searching through mainstream search engines. You'd say typically GNSS data agriculture availability medium. And then depending on how resources are described, something may pop up and direct you there. Yes, but with this profile, we ensure there is space to advertise this, and it's then picked up by search engines eventually.
Yeah, because look at the header, it's search for rights.
Yeah.
It's something very specific for like GNSS community. So how someone working in agriculture, like a farm owner, like farming company, how they can know that they can search for something called Writings 5? You know,
Exactly, that's a very good point. So adapting the user interface to what type of user come to you is crucial. Yes, so if this suggests that so far we were only expecting those people who know what a Writings farm is, and also those where to find it when it comes from course network. So further improvements are possible, but with more comprehensive metadata, assurance is that the resource is fair. Yes, it's findable, accessible, interoperable, and reusable in some way. Yes.
Thank you very much, Ivana. So join me in thanking very much, Ivana, for this first seminar in our series. If you've got any further questions, I'm sure Ivana would be very happy to take those via email.